In the video from the book, they will show you how to, if given a point here, here, and here, you can find the slopes for the linear function that you need, and then you can actually find the z-intercept, which is just great. But that really requires that these 2 points be directly, they have to be in the same row, and these 2 points would have to be in the same column. That almost never happens. For example, what happens if we get a point way down there? Now we can still do stuff with slopes and it's still pretty cool, but what I want to do is say, hey, we can use some linear algebra. So what I'm going to do is just extract the information from here, so I just write down my points, and then we'll look at the linear algebra we would have to do in order to do this problem. Now the first point I have is 7, 8, 13. So let me just put that up here like this. I want to be able to see, I can make sure I can see it. Yes, this is 7, 8, 13. The second point I have is -5 to 4. The third point I have is 3 minus 4, 9. Now I remove those points so we can just do this with linear algebra. Like I say, we can do this with slopes, and I do think it's instructive. But given our environment, let's review a little linear algebra. Remember, what we're looking for is the equation of a plane that looks like z equals mx plus ny plus b. In other words, we just want to find m, n, and b. But we know that 7, 8, 13 is supposed to be on there. That says if we put in a 7 for x and an 8 for y and a 13 for z, it's supposed to work, right? So I'm going to write down 13 equals 7m, don't know what m is, plus 8n plus b, like that. Now what is that, by the way? That's a linear function in 3 variables. But we can get more equations. I know that when I put in -5 for x and 2 for y, I'm supposed to get 4 for z. So we're going to try writing that out. We're going to write down 4 for z equals -5m plus 2n plus b. And finally, we know that if we put in 3n for x, -4 for y, and 9n for z, it's supposed to work. So I'm going to go put a 9 right here, and I'm supposed to get 3m minus 4n plus b, and this is a system of 3 equations and 3 unknowns. And in your linear algebra class, I think you probably went through 6 different ways of actually solving that. I'm going to try to do the easiest one. What I'm going to do is write down the augmented matrix. So I'm just going to write down the augmented matrix. This is going to go 7, 8, 1, it goes like that, and then -5, 2, 1, like that, and then 3, -4, 1, like that. Remember, this is called the coefficient matrix. When we add this extra column, they call that the augmented matrix. Now, by the way, augmented just means you made it bigger. Now, what are we supposed to do with this? Again, there's lots of ways of doing this. We can put this in row-reduced echelon form. And so, believe it or not, I went to something I think called rrefcalculator.com. And what I got was something that looked like 1, 0, 0, 0, 1, 0, 0, 0, 1, like that. And I got, now, I did have to look at these. It actually said something like 0.699999999, but I'm thinking 0.7 works. Same thing here. I think this is like 0.1, and I think this is like 7.3. And what does that say? That says we do have our final equation. I'm going to write it down in the one little spot I have, and with a little ta-da, like that, we're going to get z equals 0.7x plus 0.1y plus 7.3, and you should try that out, but I believe that actually works for all 3 points. So if those points are directly across rows or directly across columns, use the way from the book. It's faster, it's better, it's more instructive. If they're not, if they just seem all sort of sorts throughout the plane, just write down the 3 equations and let your linear algebra do it for you.